Thursday. So when we ended on Thursday, we were doing the half angle formulas, which is another way in which you can find the sum and difference. You can use half angles if that works for you better. So on these, I'm just asking for where the quadrant is so that you know whether or not the answer should be positive or negative. I'm not asking you to find the answer or anything. I just want to know whether or not you'll pull the positive or the negative, because all of the half angles have positive and negative, and you have to determine which one you're going to choose. Do you choose a positive answer or do you choose the negative answer? So with your partners around you, you decide on A and B whether or not you're going to be choosing a positive answer or the negative of the answer. All right, so on A, do I take the positive or the negative of it, and why? Yes?
You take the negative because that's equal to 3.
That is correct. So this one, I'm going to choose the negative. My answer should be a negative number because 222.5 degrees is in quadrant 3 and sine is negative in that quadrant. So the answer there would you choose the negative, and the reason is sine is negative in quadrant 3. What about 17 pi over 12? Yes?
That one's a positive
Why?
because it's also in the third quadrant where tangent is a positive.
So 17 pi over 12 is in quadrant number 3. Quadrant number 3, tangent is positive, so the answer should be a positive answer. Now, if you're struggling with where these land, 17 over 12, well, that's larger than 12 over 12. 12 over 12 is just 1, so if I slap on the pi here and the pi here, that 17 over 12 pi is greater than 1. So I know that I've gone at least the 180 degrees, or I've gone a pi rotation. Now, if I pull off that 12 pi to figure out whether or not I'm into the next quadrant or not, so I know I'm at least in quadrant 3, possibly quadrant 4. If I pull off a pull off a 12 pi out of there, I end up with 5 pi over 12. 5 pi over 12 is less than halfway. So I know 17 pi over 12 is in quadrant number 3. So, and if you can always just use your calculator and do 17 divided by 12. What is 17 divided by 12? 1 point something. 1 point what? You all have calculators in front of you. 17 divided by 12. So 1.4-ish pi. So I know that I have not gone 1.5 pi. So that's why I knew it was a positive number. Cosine of 100 degrees. Do I take the positive and negative, and why? Why the negative? So 100 degrees is in quadrant 2. Cosine is negative in quadrant 2, so I'm going to take the negative of the answer. Okay? Any questions on those?
Yeah, why don't we have to do any of that stuff under the radical?
Because the directions were determine if it's positive or negative. That was it. And there's one on the test like this. Exactly verbatim, except for I'll ask why.
But those two things equal each other? Just whether it's positive or negative?
I'm not sure I understand what your question is.
So if you had if you took the square root of 1 minus the cosine of 4 whatever degrees divided by 2, it equal the sine. Those two equal each other?
Yes, because those, so the question is, does this side equal this side? And the answer is yes, because that's one of our identities. These are given to us to have angle formulas. All right, on this one we still have some more joy and fun. Please write these down or make sure you know where they are on your formula sheet, which would be the most ideal thing to do, is figure out where these are on your formula sheet, rather than taking the time to write them down. I'll give you a moment though, make sure you can find them. Lastly, this is our last ones, which are the sum to product formulas. So make sure you know where those are on your formula sheets. Please don't take the time to write these down. All right, So now the rest of this is just proving these identities. Oh look, the joy continues. Which one would you like me all to do? The very last one? C is looking good though. This one? Okay. All right, so to prove these identities, and you had your homework graded, the hand-in part, and I forgot to bring it with me. Most of you all did a really good job of declaring the side that you're working on. What side would you like me to work on? The right-hand side? I would have chose the left hand, but I will choose the right hand. So right-hand side, I'm going to rewrite this as the tangent of h divided by h, and then it's the secant squared of t, 1 minus the tangent of t, tangent of h. So I have this rule that says if I have a over b multiplied by c over d, I can write this as AC BD, or I can write this as CA over BD. So I can write this as C over B, A divided by D. Okay? So I can rearrange things as I need. Now I have secant squared. I see secant squared there, and I have some tangents going on, and what I'm going to do is I'm going to replace my secant with a tangent if I have that equivalence. Do I have a secant tangent replacement? Looking at your identity sheet. What is secant squared equal to?
Tangent squared beta plus 1.
So this is going to equal to tangent squared t plus 1. Right? So this is going to equal to the tangent of h over h multiplied by the tangent squared of t plus 1 over 1 minus the tangent h, the tangent t. Now, eye on the prize. I need to have the tangent of h, or t plus h minus the tangent of t all over h. So with that information, I know that I'm not going to do anything with this h. It's just going to continue to come along for the ride. Now what? What do y'all want to do now? I stare. You all stare back. Yes?
Can't you multiply between h and cosine and h in the bottom?
So the question was, can I do this cancellation here and here? And the answer is no, and this is why. If I have a plus b, or even with multiplication, let's do a b plus 1 over 1 minus a b squared, right? That order of operations says I have to do what's in the numerator in parentheses first. I need to do what's in the denominator in parentheses as well. I've got to take care of my power. And then I get to do the reduction. So if that's the case, then there's no way that I can take a factor and divide it into a term. So those won't happen. So the a in the numerator is a factor. The a in the denominator is a term. All I can do is cancel factors. Yes? So the same kind of thing is I'm not allowed to do that cancellation. I'm just going to put that b squared there. So this is what you have between these two. You basically have, one of the things about identities is let's turn it into x's and y's to make our life easier, okay? Or a's and b's if you like. So if I replace the tangent of h, everywhere I see that I'm going to call that a, and everywhere I see the tangent squared of, or the tangent of t, I'm going to replace that with b. Then what I equivalently have is a b squared plus 1 over, I'm going to ignore the h because we're just going to keep that, it's going to come along for the ride, 1 minus ab. So this is what I basically have. Algebraically, what kind of things can I do to get from one to the other? So let's go ahead and distribute the a and see what happens. So I have a b squared plus a over 1 minus ab. Did that help me at all? Did that help me at all? So if you get stuck, what you want to do, because you can't work both sides, but you can, if you get stuck, work the other side. Okay? So if you get stuck, you want to try considering using the other side. So let's say, okay, well, let's put this on pause and let's choose the left-hand side. So the left-hand side is the tangent of x plus h minus the tangent of t all over h. So if you get stuck on these, and you will, don't give up, try the other side. Just because the other side has less terms in it doesn't mean it's not the side you want to choose. So we know the tangent of t plus h is the tangent of t plus the tangent of h all over 1 minus the tangent of t, the tangent of h. And all I've done is replaced the sum of angles for tangent with its identity. Question?
Yeah, how'd you get the 1 minus tangent t on the bottom?
So we have an identity for this. We have a replacement identity for this. So look on your formula sheet and look for the sum of tangents on your formula sheet. So we have an identity for it. Did you all see the identity for this? Okay. What I have is a complex fraction, right? I have a fraction within a fraction. How do I get rid of a fraction within a fraction? I multiply by a common denominator throughout the entire thing. My common denominator is going to be this. So I'm going to multiply each term by that. I'm going to multiply the denominator by that. I'm going to multiply this term by that. And I'm going to multiply this term by that. I multiply every term by my common denominator so that I can get rid of my complex fraction. I end up with the tangent of t plus the tangent of h minus the tangent of t, 1 minus the tangent of t, tangent of h, all over h, 1 minus the tangent of t, the tangent of h. So if we take a look, eye on the prize, we're actually getting closer to do the right-hand side than when we started with the right-hand side. Because right now, the right-hand side has this in the denominator, so we're getting closer by choosing the other side. All right, so now what I have basically is I have a plus b minus a, 1 minus ab, all over the denominator. I don't care about the denominator at the moment because that's what I need. So I need to take that, and my numerator is going to, well, I need tangent h by itself. So basically I need to get b all by itself. How would I do this? What if I were to distribute that negative a through? Then where am I? So I have if I were to distribute the negative a through, I'd have a plus b minus a plus a squared b. I combine like terms. What happens to my a's? They end up canceling out, right? So then I would just have b minus a squared b. Then what? What would I do there? Factor out of b. How are we doing? Oh, that should be a plus. Then what? Are we good at there? So let's apply our algebra with a's and b's, what we just did algebraically with a's and b's to make our life easier, to the tangents that we just had. So the first thing I did here on this step is I multiplied that negative a through, yes? So I'm going to go back and I'm going to multiply the negative tangent t through. So this is going to be equal to, actually, you know what, I'm going to put this is going to be equal to the tangent of t plus the tangent of h minus the tangent of t plus the tangent of t, tangent squared t, tangent of h. All over that denominator, which is 1, h minus 1 minus tangent h, tangent t. All right, so I am at this step right here. What did I do at the next step?
What was the denominator? Tangent h, tangent t?
Right there, the denominator is right here. Right here. So what did I do on this next step? So what am I going to do here? I'm going to combine like terms. My tangent t's are going to cancel themselves out. So I end up with, in the numerator, I'm going to end up with a tangent of h. Oops, I canceled the wrong thing out. This one gets canceled out. So this is equal to the tangent of h plus the tangent squared of t, tangent of h, over my denominator. So going back to my a's and b's, what did I do at this step from here to here? So I'm going to come back here and I'm going to factor out a tangent h. So the tangent of h, 1 plus the tangent squared of t over h, 1 minus the tangent of h, tangent of t. And there's my secant squared. So this is equal to the tangent of h, secant squared of t, all over h, 1 minus the tangent h, the tangent t, which is the right-hand side. Yeah, I'm going back. So this equals the right-hand side. So if you get stuck, do two things. Consider working the other side. And consider replacing everything with a's and b's, and how would you do it algebraically? Because I know you all can do the algebra. I know you all know how to factor out an a. I know you all know how to cancel terms. If you get stuck, turn everything into a's and b's, or x's and y's if you're in sine and cosine. And you'll be fine. Yes?
When did you know how to use the tangent formula for that? You just saw it immediately. How did you?
So the question was, how did I know to do the left-hand side was going to be the easier one? Is because I seen this denominator here, I seen that. And that screams the denominator of the sum of tangent. So if you look at the sum of tangent, you're going to see 1 minus on the denominator, if you have a sum, you're going to see 1 minus the tangent theta, tangent alpha and beta, if you're using alpha beta. It's 1 minus tangent alpha, tangent beta. So because of the fact that I know that the tangent of alpha plus beta is this denominator, that's how come I knew I wanted to choose the left-hand side. I knew that that side was going to be the easier one. How was that? All right, so I'm going to come back up here, and you have all those identities with you and your partner. Okay, so let's take a look at the first one, and this is really, really, really important. You have to do this on the test if you want full credit, because you have to declare the side. I'm going to choose the left-hand side. And then you have to rewrite that side before you start working with it. And this is important because if you don't, and you make me guess, I'm going to guess wrong every time, and you're not going to get full credit. I'm not even going to look at it, actually, unless you've declared it and then rewrote it. So I'm going to start with a sine of 2 beta. And the reason I'm doing this is because the right-hand side kind of looks like, why did I choose this side? Because the right-hand side kind of looks like the double angle. I see a 2 there. But it's sine, but we'll work that out. So I am going to use a double angle, and so this is going to be 2, the sine of beta, cosine of beta. So I have got a 2, and I've got the sine of beta. What I need is another sine. So I have a cofunction identity. And so the cofunction identity for this is the cosine of beta is equal to the sine of pi minus beta, pi over 2 minus beta. What I want is beta minus pi. And I have this rule that says if I have a minus b, this is equal to a negative a plus b, which means this is equal to a negative b minus a. So knowing that, then up here I have 2, the sine of beta, the sine of the negative of beta minus pi over 2. But sine, is that odd or even? Odd. And so that negative, which is right here, will factor out front of the sine, which I'm going to put it in front of the 2. And so my final answer is negative 2, the sine beta, the sine of beta minus pi over 2. And I have the right-hand side. How was that? It was magical. All right, any questions on this? Cool. So if you all could start on the second one then. The hint for B is we know that 4x, this is the hint for B, we know that 4x is the same thing as 2 times 2x. So that's the hint for B. Many of you have seen this for the first time here. So it's okay if you're struggling still. It is totally fine to struggle through this entire section. By the end of the quarter, you won't be struggling as much. And I didn't say you won't be struggling at all. You won't be struggling as much. So I make it look easy because I've done this a million times. This is like, oh, I know what these are off the top of my head. I know which side to choose. The reason I'm going to choose the left-hand side is because I know the double angle right off the top of my head. I know how to do the double angle. And the right-hand side, as I take a look at this right-hand side, and this doesn't have anything that I'm really comfortable and familiar with. It doesn't look like the sum of difference of squares right off the top of my head. Because it doesn't look like the sum of difference of squares, then I'm just going to leave that side and go with my left-hand side because I know the double angles. And that's why I'm going to choose the left-hand side. So I'm going to choose the left-hand side, and I have the sine of 4x over 4. I'm going to rewrite this as the sine of 2 times 2x over 4. Now, if I look at my double angles, this 2x is going to act like theta does for my double angles. And so this is going to be equal to 2, the sine, my theta, cosine of my theta, all over 4. Again, that 2x, the way I wrote it, that 2x is going to act like the theta does. Now my x's, or now my 2's canceled, so this 2 and this 4 will cancel down to a 2, so I'm getting rid of that denominator slowly. Now I'm going to use the double angle yet again because I see the double angle in there. So this is going to be equal to the sine of my theta, which happens to be x, the cosine of my theta, which happens to be x. Now that part that I just wrote here is that part right there. All right? So now I have to use the double angle for cosine, and I have 3 choices. My first choice is the cosine of 2 theta is equal to the cosine squared theta minus the sine squared theta. That's one choice. Another choice is I have the cosine squared theta minus 1. And then my third choice is the 1 minus 2 sine squared theta. Those are my 3 choices. Now, I know right now in the denominator I have a 2 still. That is still coming along. And I also know that this 2 out front is going to cancel with that 2. Keeping my eye on the prize, I look at what the right-hand side is. That right-hand side does not have 2 anywhere in it. So I'm not going to choose the second 2. I'm going to choose that first one. Again, I'm looking here, right here. That's my eye on the prize. It does not have a 2 in it. And I've already eliminated the 2 in the numerator and the denominator. So I am going to choose the top one because that's the one that does not have a 2 in it. So I'm going to replace cosine 2x with cosine 2x, cosine squared x minus the sine squared x. Again, I'm replacing this cosine 2x with its double angle. And I chose that one because the other side doesn't have any 2's associated to it. So what I now have is, let me erase this other part that I don't need. I don't need this part anymore. So what I now have with distributing it through and my numerator 2 and my denominator 2 canceled is I'm going to get the sine x cosine cubed x, because I have a cosine squared times another cosine. And then minus the sine cubed x, because I have a sine squared multiplied by another sine. And then I have the cosine of x, and I end up with the right-hand side. Yes?
How can you treat that 4x to where you treat the 2x as theta in one part of the problem, and then you turn it into, then you use that same double, whatever you call it.
Okay. So the question is, how am I able to take sine 4x and treat it like the double angle? So let 2x equal theta.
How did you, so you let 2x equal theta, and then you made x equal theta in the second part of the problem.
Well, I just said it was in reference to a theta. It's like a theta. So you notice that every time I put it in there, I didn't actually use theta, I used x, but I referenced the identity as theta.
So that's how you have to do it.
Yeah. Yep. Okay. Please consider trying the rest of these. I'll be around today. Tomorrow, make sure you meet with your advisor. If I'm available, you can come ask me questions. You're going to get a take-home on these. I would recommend you practicing these, and I'll upload the video today. Have a great day. All right, so let's take a look at C. We're going to go ahead and prove this identity, and I'm going to choose the left-hand side. The reason I'm choosing the left-hand side is because, again, I know the double angle formula fairly well, so I'm going to choose the side that I know the best. So if I choose the left-hand side, I have the cosine of 4 theta is equal to, I'm going to write this as the cosine of 2 theta, just like I did in the previous example. So then this is going to be equal to, using the double angle. Now, as I'm looking at this, I realized that on the right-hand side, I see a bunch of cosines. Because I see a bunch of cosines, I'm going to use, on my double angle, I'm going to use the one that is the cosine of 2x is equal to cosine 2 cosine squared x minus 1. That's what I'm going to use probably each time. Okay, so then let me do this. So this is going to be equal to 2 cosine 2 theta, it's cosine squared 2 theta, minus 1. And I'm going to use the double angle yet again. So this is going to be equal to 2, and then in parentheses. So when I use the double angle, though, remember that because this is squared, so this is the cosine of 2 theta squared is the same thing as the cosine 2 theta multiplied by the cosine 2 theta. So I'm going to use the double angle, but then I need to square that. So this cosine squared 2 theta is going to be 2 cosine theta and squared, cosine squared theta, minus 1. And then it has to be squared because, again, up here, what I have is the cosine squared 2 theta is going to be cosine 2 theta times cosine 2 theta, which means what I really have is 2 cosine squared theta minus 1, put the quantity squared. So then this is going to be equal to, and what I'm doing here is I have 2x, something that looks like this, is 2a squared minus 1, the quantity squared. Using this, the fact that it's a perfect square trinomial, it'll be 4a to the 4th minus 4a squared minus plus 1. So using the same kind of rules as the perfect square trinomial, this part right here will become 4 cosine to the 4th theta minus 4 cosine squared theta plus 1. And then parenthesis minus 1. So what I have next is I'm going to take the 2 and distribute it through. So I have 2 times 4, which is 8, cosine squared theta, minus 2 times 4 is 8, cosine squared theta, plus 2 minus 1. Now this should be to the 4th power. So this is equal to 8 cosine to the 4th theta minus 8 cosine squared theta plus 1, which is equal to the right-hand side. So let's take a look at our next example. If we take a look at D, I have the sine of mu minus the cosine of mu, the quantity squared, and then 1 minus the sine 2 mu. It doesn't matter which side you choose. Let's choose the right-hand side this time. So I'm going to choose the right-hand side. So I have 1 minus the sine of 2 mu. Now I'm going to use the double angle. If you notice, I really like the double angle, so I'm going to use the double angle. So this is going to be equal to 1 minus 2 the sine mu, the cosine mu. But remember that 1 I can replace with the sine squared mu plus the cosine squared mu all day long, because we know that the sine squared theta plus the cosine squared theta is equal to 1. So that means that I can replace my sine, I can replace that 1 with sine squared minus or plus cosine squared. So this is equal to the sine squared mu plus the cosine squared mu. Now remember, I'm replacing this number 1 with that. and then minus 2 the sine mu cosine mu. I'm just going to reorder this and reorganize it. So I'm going to write this as the sine squared mu minus 2 the sine mu cosine mu plus the cosine squared mu. And what this looks like is it looks like I have a squared minus 2ab plus b squared, which is a perfect square trinomial. So that means that this is going to equal to the sine mu minus the cosine of mu, the quantity squared, which is the left-hand side. All right, let's take a look at our next example. If we take a look at our next example, we have the sine of alpha plus beta, the sine of alpha minus beta. So again, it doesn't matter which side you choose. If you're going to choose the left-hand side, then what you're going to do is you're going to use the sum and difference for sine. If you're going to choose the right-hand side, you're going to take everything and turn it into sine and cosine. So I'm going to choose the right-hand side. It doesn't matter which side you choose. So I'm going to choose the right-hand side. The right-hand side is 1 plus the cotangent alpha, tangent of beta, over 1 minus the cotangent alpha, cotangent beta, tangent beta. Let me erase that. So tangent of beta. And what I'm going to do is I'm going to turn all of my left-hand side, or all of my values on the right-hand side in terms of sine and cosine. So this is going to be equal to 1 plus, cotangent is the cosine of alpha, the sine of alpha. Tangent is the the sine of beta divided by the cosine of beta. My denominator is 1 minus the cosine of alpha, the sine of alpha, and then multiplied by the sine of beta, the cosine of beta. Now, what I have is I have this complex fraction. I have a fraction within a fraction. I see this fraction and this fraction within a fraction. So what I like to do is I like to clear my fractions by multiplying by my lowest common denominator. My lowest common denominator of all of my fractions within the fraction, is sine alpha cosine beta. So I'm going to multiply this by the sine alpha cosine beta. I'm going to multiply this by the sine alpha cosine beta. I'm going to multiply this number 1 by the sine alpha cosine beta. Multiply this number 1 by the sine alpha cosine beta. When I do that, I'm going to have here, let me get some more room here, is when I multiply my 1 by the sine alpha cosine beta, I'm just going to get the sine alpha cosine beta, plus when I multiply the sine alpha sine beta by that second term, my sine alphas cancel and my cosine betas cancel, leaving me with the cosine of alpha and the sine of beta. In the denominator, I'm going to have something similar. I'm going to multiply the sine alpha cosine beta by 1, so I get the sine alpha cosine beta minus, and when I multiply the sine alpha cosine beta by the second term in the denominator, again, my sines will cancel and my cosines will cancel, leaving me the the cosine alpha, the sine beta, which the numerator is the sum of angles for sine, so sine alpha plus beta. The denominator is the difference of sine alpha minus beta, and this gives me my left-hand side. All right, let's take a look at our next example. On this next example, I'm going to choose the left-hand side. So, choosing the left-hand side, I have 1 minus the sine squared gamma divided by 2. Awful. Divided by 2. Over 1 plus the sine squared of gamma divided by 2. Now, I don't have a sine squared gamma divided by 2, but I do have this one. I have this one that is the sine of some angle divided by 2 is equal to plus or minus, and it is 1 minus the cosine of my angle divided by 2. So that means if I have sine squared alpha divided by 2, I must have 2 of these. So the sine of theta divided by 2 multiplied by the sine of theta divided by 2, which means that this is equal to the square root of 1 minus the cosine theta divided by 2, and that is squared. Now, we don't have to worry about the plus and minus on this because we are squaring it. Because we're squaring it, we don't have to worry about the plus and minus. So I know that this will then equal 1 minus the cosine of theta divided by 2. So I'm going to replace this here and here. Okay, so this is going to be equal to 1 minus 1 over the cosine of theta divided by 2 over 1 plus the sine of, the sine of 1 minus the cosine of theta all divided by 2. I'm going to multiply everything by 2 over 1 so that I can clear my complex fraction. So this is going to be equal to 2 minus 1 minus the cosine theta, 2 plus 1 minus the cosine of theta. Oh, these are all gammas. I should go back and change that. These are all gammas. So that's a gamma, that's a gamma, that's a gamma, that's a gamma. So these need to be gammas. So gamma, 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 and gamma. So this is going to equal to 2 minus 1 minus a minus becomes plus cosine gamma. In the denominator, I have 2 plus 1 minus the cosine of gamma. So my numerator becomes 2 minus 1 is 1 plus the cosine of gamma. In the denominator, I'm going to get 3 minus the cosine of gamma, which is the right-hand side. Now I'll go ahead and make a video on these last couple of identities that we haven't done. As this video is already quite long, I'm going to go ahead and stop it here, and then I will do a video on these other 4 that I haven't done yet.